Hello everyone, so welcome to my channel. Today we are going to do Leetcode daily challenge, Roman to integer, and this is Leetcode easy based question. So as we all know that easy based questions are in such a manner that whatsoever is being written there, we need to do it as it is manner, and even the constraints which would be there, that would be also in such a manner that even brute force would work. But here I'll let you know about the approach in which we would be using the mathematical concept of converting it, although still it would be having some space complexity and not space complexity. Um, yeah, there would be space complexity and even the time complexity would also be order of n, we can say, but that would be according to the length of the string which is given to us. So it is already 15. So I guess even if we say that this 15 is such a constant or such a small number, so then again in that context also we can say that time complexity is order 1, but we can't say that when it is given to us that it is of 15. So we are required to give it as order of n. Now let us see this question, that how it is means. Let me explain you, then after that we'll come to the approach. So Roman numerals are represented by 7 different letters that we all know that what all 7 are, and we need to pay attention to these 7 letters in this and need to transform our answer. So for example, 2 is written as this, means this plus this one which is being given to us. So accordingly we are writing 2 like this, as we all know, just 2 ones added together, and 12 is written as 10 and then 2, which is simply 10 plus 2. The number 27 is written as, first there would be 20 and then there would be 7, that is 20 plus 5 plus 2. So this is how 27 is written. So keeping in mind about these things only, now let us read some more, then I'll let you know. Roman numerals are usually written largest to smallest from left to right. Okay, this gave us one clue point. Also, we already know about this, but still, this gives us clue point about our approach, that how we can go ahead. Now next is, however, the numeral for 4 is not 4. Instead, the 4 is written as 1 and then 5. That simply means that if we check from the last one and we check that in the last character which is being there, if that is greater than our left character, then we are required to subtract our last character with the left side character. That is the thing. So because the 1 is before the 5 is subtracted, making 4. So this is the thing which we are required to use in our approach, because this will make us to map correctly about by traversing the given string character by character, but from last side. And the same principle applies to the number 9, which is written as 1 and then 10. There are 6 instances where subtraction is used. 1 can be placed before 5 and 10 to make 4 and 9. 10 can be placed before L, that is 50, C, that is 100, to make 40 and 90, and C can be placed before D, that is 500, M, that is 1000, to make 400 and 900. So these are some of the clues they just gave us, that like this we can use our like these things we can use to basically come up with our solution. So at the end, what we are required, that given a Roman numeral, convert it to an integer. So this is the thing which the question asks us to do. So now let me first give an example, that how I was saying that means that how we can go ahead with the same. So let me open up the code. So here, see how the things could be. If we check for this 3, if we store this last one, see if we map our I with 1, then 5 with 5, in a particular map, either we use map or vector or any data structure, we just want to map it. But we will prefer an unordered map over this, and why we prefer is because we can easily look up into the same. That's why we prefer unordered map. That would be one of the best option to go ahead with. So that was about the mapping. But how we came to conclusion that we want to use map, because we would be means why we want to do mapping. So now before going to that, let me show you that how it comes out. See, we start from the last character because everything starts. We all know that we are reading a Roman numeral from left to right, right? If we say this, so we are reading like there is 10 and then there is 6, right? Or if it is something like this, that there is 10 and there is 4, right? But now comes the part that if this 3 is there, then if we check from the last one, and then if we check for the left one, means if we compare both of them, they are equal, right? So when they are equal, we are adding them, and thus we are doing so. And then we again check that about this one and this one, right? And then again they are equal, so we'll add and then we'll get our answer, which is equals to 3. Now comes the part for this 4. So in our end, we will be starting from the end and we'll check that what is to the left side of this particular, because we go from this side, right? Then 10 is there and then 5 is there. How comparison would be possible? That do we need to add into the same, or do we need to subtract into the same? But if we go from this last one, then surely we can compare that what we need to do with both of these, right? So that's why we are required to start from this last one and compare with this one, and that's what we are doing. We are directly just storing this 5 and then comparing with this particular one, and then we are checking that if this one is basically less than 5 years, so we will subtract this one from our 5 and we'll get our answer. And then when there is only single digit, so we need to store as it is. From our map we will get our 5. Then if we are having this 1 stored, right, and then we are having this 6, so 6 is 5, so 5 is basically greater than 1, right? So that's why what we are required to do here is we simply required to add them up, and that would be our answer. So this is the thing which we need to think and come up with and need to code the solution. So just think about it, that how you will be coding the same, because for each string, each character, we are required to have a particular number related to it. Means I is related to 1, 5 is related to, V is related to 5, X is related to 10. So all these things which we are required to do in the mapping. And this particular mapping will give us, for this particular algorithm which we are performing, that we are storing the last digit, last character which is there, and then last character is basically mapped to an integer, and that integer is being stored into our sum. And then we are comparing that if the leftmost is basically greater, then we are adding to the same. If it is smaller, then we are subtracting that particular left character's mapped digit with the sum which is being stored, as we were doing here. So this is how we need to go and come up with our approach. Now comes the part that what would be the time complexity, because we would be traversing the string, so it will be directly equal to order of n, and n will represent to the string, which is characters, or you can say length of the string. That is n here. And the space complexity, this mapping part which is there, because of this the space complexity will become order of n. That would be the thing here. But the constraints are in such a manner that the string could be at max 15, the stored these things are only 7. So again you can say that it is order of 7 and it is order of 15 at max. So both of them are somehow constant only, but still as per the constraint given, so we are required to take it as order of n, both of them. But the storage which we are using, that won't exceed the 7, means it won't reach up to 15 even. That's why at that moment of time, we can say both of these directly only, that the space complexity is order of 7, it is a constant, so order of 1, we can conclude. And the time complexity is at max order of 15. So that's why that n converts to 15, that's order of 1. So now let me walk you through the code, that how we are required to code this particular solution. So here we go with the code, or let us write this code together. That also we can do. Okay, yeah, it would be better. Let us write this code. So here comes the part, that first thing is that we require an unordered map for storing these particular things which are there. That is already given, so we can directly just use from there. Means quickly we can, rather than recalling, because in our junior classes only we had read all this. So with time we forget. So the first one is char and the other one is int, right? And let us name it as t. T simply represent our table here. Now this is the thing how we would be storing here. So let us start with storing part. Yeah, particular should be like here. First we are storing with our I which is there, and that I is basically mapped to 1, and then we are storing our 5, and 5 is basically mapped to V, which is basically mapped to 5, and then we are going to store our X, which is basically mapped to 10, and then we are required to store L, and it is mapped to 50, and then C is there, C is mapped to 100, then we are given this D, 500, and 1000. So these are the ones which are being given to us. So our table is now ready. Now comes the part that how we are required to use this table. So first, as we at the end required to return the sum, that is what, because each number is basically sum only, that 5, that V and I which was there, that add up to 6, right? Or any other which we split, that is, it is basically sum. Even if sometimes we are required to subtract also, so overall let us take it as sum only, that in sum equals to, as we are starting from the back side, right, and it is a string, so we can use this, and then we would be starting our loop. Now here comes the part that how we are required to start our loop with, so that easily we can compare. Earlier we have already put our that last one which is there in our sum. So we will here starting with x of length minus 2, and because we are starting from the back, that's why we are writing like this. And this is how we would be doing, so that our comparison becomes easy, and even there is no runtime error in the same, and out of bound things, they should also be not there. So that's why. Now we are comparing here that our present, which is there, is it greater than my next question, which I would be going ahead with, is basically s length of s minus 1, and the previous one is length of s minus 2. So this is both of them comparing with each other. And now comes the part, if this is the criteria, that is, if we are encountering with I and then we are encountering with Y, that is the thing which is there, then in that criteria we simply are required to subtract, because 5 would have been already stored there, and now we are just required to subtract that I from it, so that it becomes 4, because this is the value for 4 only. And now comes the part that if it is basically greater than or even it is equals to, then in that criteria we would be required to add. That was a scene for 3, 2 and even the 6. So that's why we are doing this. So this is the thing which we will be doing, and at the end we are just required to return our sum. So now if we run this particular, it will work, and even if we submit, then also it should work. Oh, type only. Even in the small program. That's so bad. So this was here, and if we submit it, then it will again work. Yeah. So it worked, and now the time complexity and space complexity. Time complexity is because of this only, because in this particular time complexity is just order of 1 only, because we are just doing this lookup into our map. So major time complexity comes up from this loop. So this loop is order of n, and the space complexity is because of this only. So here you can directly see that where the 7 spaces which would be filled. So that's why the space complexity is 7, but we'll take it as order of n. And here again the time complexity is order of n, but here n value basically varies. Here n represents the 7 and here n represents the length of the s. So that's how the time complexity and space complexity for the same is. So this was all for today's Leetcode daily challenge. If you have any doubt, you could comment that down. So thank you.